Alrighty, and here we are again, ready to learn and take some notes. All right, we are in the final unit for Algebra 2. Okay, one good thing, we have 11 lessons left. Okay, we are going to have no quiz during this lesson or this unit because I am just running out of time. You will have one last test. I said last test, not final test. You will have a Unit 8 test that will be given to you probably May 14th. You know what? We'll probably go with May 14th. Okay. If that works out in my lesson, but let's shoot for May 14th or May 15th. So that means that if you are finished with those two values, you are finished with Algebra 2. This will have a due date on the last day of that's technically supposed to be school. It's supposed to be our last day of school is May 19th, but that's just going to be the due date for your test. Okay, so no quiz, one Unit 8 lesson left. Some of you, again, are on that borderline of pass-fail, so you might want to do well and pass this test so you can pass Algebra 2. All right, so because if I put this as an incomplete, or if I put this in just even as a pass and your grade doesn't go up, that's your grade, guys. Okay, so do something to help yourself. All right, the last unit is called exponential functions. But luckily, we're actually going to take out the graphing part for this section because I don't really have time for it. And if for those of you going on a pre-calc, well, you'll hit it again anyway. All right, so exponential growth and decay are in this form. Basically, you have an a value and a b value taken to an x power. So this one has an a value of 1. This one also has an a value of 1. But it is this b value that determines the shape of the function, whether it's a growth or whether it's a decay. When that b value is between 0 and 1, we get what's called an exponential decay. When that b value is greater than 1, you get an exponential growth. Okay, now b cannot be equal to 1, otherwise it'd just be a straight line. So it either has to be between 0 and 1 or it has to be greater than 1. It also cannot be negative because you're typically speaking, exponential growth and decay are talking about real life things where you have to have a multiplier that's a positive value. Okay, so let's talk about those real life things today. These are modeling with a constant percent of increase or decreasing called a growth factor or decay factor. So once again, it's based loosely off of this a times b to the x value. But when we're looking at this growth and decay, we have two formulas, very slight differences. We have what's called a equals p times 1 plus r to the t, or decay. What do you think the difference is? Growth. Decay. All right, so it is a difference of a positive or negative. So we have p times 1 minus r to the t power. So this is kind of like the shape creator. This is whether or not it's going to be an exponential growth or decay. And then we have this exponential power. All right, whoops. Wrong key. So let's talk about what these variables mean. The A. This means the total amount. Total amount. Okay, so that total amount is money, population. That's all I can think of right now. So it's just a total amount of something. The P is what's called the principal. Whoops, misspelled that. Okay, principal. And what does that actually means that it is the initial value. Where did this information start? How much did it start with? You know, if you're buying a house, when you take out a loan, you have a principal amount. My house cost, I don't know, $200,000. That's your principal amount. Now they'll tack on interest to that, but that's what it started at. So that's the principal. All right, R is the rate. And this rate is your percentage rate. Okay, it's like a loan. When you took out a loan, they gave you a percentage rate. So that's money that they're going to keep adding on to your principal amount. that needs to be in decimal form. Let's do a quick review. 30% as a decimal. Anyone? Anyone? Yes, it's 0.30. You have to, here is where the decimal was right there. You need to move it 2 places to the left at all times when you're converting it to a decimal. So what is 5% as a decimal? Well, here's the decimal place. We move it 2 places. That's 0.05. That's as the decimal. Okay, it always has to be in decimal form. And then lastly, the T stands for time. How long did you take the loan out for? How much time passed as you were taking a survey? Okay, it's just some sort of form of time. All right, so I'm going to do one example. You're going to do another one as your homework, because they're pretty straightforward. You just got to fill in the pieces, okay? Is it an A? Is it a P? Is it an R? Is it a T? You got to figure out. You'll be given 3 of those 4, and then you just have to solve for the 4th one. Okay, first U.S. Census was conducted in 1790. Hopefully your parents filled out the U.S. Census, all right, because, you know, it's the law. I filled out mine. All right, at the time, the population was 3,929,214. Okay, so I'm trying to go in order here. Okay, so yellow would be time. We'll go with this green. What do we think the green would be? Oh, yes, the green is the principal amount because that's when it started. U.S. population has grown approximately by 2.03%. So we'll go with teal on this one. So that is the rate. And then what was the approximate population in the U.S. in 2014? Okay, so that is part of the time. And lastly, we'll go with this fuchsia here. What was the approximate population? So that's this part here. Okay, so then you just have to fill it all in. Ooh, let's go with brown. All right, so we don't know the total amount. That's what I'm looking for. I do know that it started with 3,929,214 people. I always have that 1 there. I have my rate as 2.03%, but as a decimal, that's 0.0203. So we put in 0.0203. Then I have to take that to the T power. How much time is gone between 1790 and 2014? How much time had it had to grow? Be 224. I just got that by subtraction. Okay. Please, 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 please type this into your calculator straight like this. I see so many mistakes all the time when people try to chunk this up and do it separately. Why you'd want to do that anyway, I don't know. Just type it in. Here, I'll read it to you. 3929214 parenthesis 1 plus 0.0203 parenthesis carrot top, take it to the power of 224 equals. Ooh, quite a large number. All right, so we have 3, 5, 4, 2, 8, 4, 6, 1. Ooh, I was going to put 4, but you can't have a half a person or a 0.7 of a person, so we're just going to make, erase. So we're just going to make that a 5. That is, oh my goodness. All right, so we went from 3 million to 354 million in 2014. All right, so that's how many people we had. Okie dokie. Here is your assigned problem that you will, it will stop here in a moment. You'll be forced to answer this question. Let me do a little heads up here. The 7, whoops, didn't mean to. I was trying to do a highlighter. Okay, there we go. All right, please do not convert this to 70. Don't actually write it out as 79.7 billion. All right, you just use 79.7. We'll use billion as a label. You'll see that when the multiple choice comes up. All right, so that's your problem. Go. All right, example 3. All true, by the way. This is my sweet car. Sweet gold Kia. All right. A new car depreciates at a rate of 17 or 16% per year. I bought my sweet, awesome Kia Sedona in 2007. Yeah, that's right. It's like 13,000 or 13 years old. It's still kicking though. For 24,550. How much is it currently worth in 2017? All right, it's pretty much same straightforward here. We got time. We got, oh, I should have changed that to this year. You know, let's just do that for fun, okay? So maybe it's worth negative now, I don't know. Let's change that to 2020. You know, if you want to write the 17, you can. Let's see what it's worth today. So there's my time. I forget what colors I use. This was the principal. That's the original amount. And then I have my rate. And I'm looking for how much it's worth now. That was the A value. All right. So we got, what is it worth now? When I bought it for 24,550. It's one. Now it's a depreciation. Depreciates. That's a minus 0.16. Okay, 2007 to 2020, that is 13 years. Okay, so we just figure out what our amount is. 24550, parenthesis 1 minus 0.16 to the 13th. Yeah, all right, it's not negative. It's got quite a few miles on it though, so I doubt it would be. I don't think I would get this much money for it, but maybe I'd be lucky. $2,544.97 approximately. Woohoo! All right. Must be because it's made of gold, right? Okay. So here is your assigned problem. It is also a depression or a decay value because it's declining. This is all true, by the way. So, you know, fun fact, it is all true. All right. And then you're also going to do, okay. So this one stopped. Boom. So you stop there. Great. You did that problem. Okay, this one also is assigned to you, but again, make sure it is talking about growth. It grew from to, so just a little hint, help you out. It grew from this to that. Okay, and you're looking for percent, so figure that out in your problem. Okay, now go do that one. How are we doing on time here? Ooh, 12 minutes, yikes, okay. This one's a little bit longer than I thought it was going to be. Okay, this one's compound interest. It's just another formula. Basically, compound interest is, hold on, I'm going to cough. And I'm back. All right, so compound interest is interest paid on the principal, which is the initial deposit of an investment, and any previously earned interest. All right, and this is usually how banks go with this, is this compound interest. I would consider the other thing to be called simple interest. This is compound interest. So the good thing is that the A, the P, the R, the T are all the same thing. There's just this new term, this N. So once again, A is amount, P is the principal, R is the rate, also still is a decimal, T is still time. Okay, but this N is the number, not hashtag, guys, number of times compounded. Number of times compounded, or hashtag times compounded. All right, so you guys could start a new trend there, hashtag times compounded. Okay, so if an account, just going over some things to make sure we know our terminology here. If an account is compounded annually, the N, or I should say number of times compounded per year. All right, so annually, 1, semi-annually, 2, quarterly, 4, monthly, 12, weekly, 52, daily, 3, 6, 5. Okay, you would think if someone was compounded daily that you would be making like way more money. It really doesn't work out that way, guys. I'm just saying. All right, so so the difference is when you see this word right there, because you're gonna be like, how do I know the difference between compounded you know, when I use compounded or when I use simple interest. It's that word. Okay. Notice up here, these did not have any of that, did not have that word in there, compounded. Okay, if it has the word compounded, you need to be using the new formula, which I forgot to write down. So here we go. Here's the formula. Oh, there, it was supposed to go right there. Here it goes. Okay, so A equals P times 1 plus R over N to the product of N times T. Rate over N to the NT. Okay, so it's similar. So we have 1 plus rate, and we have time up there, but then we just have to plug in that compounded. Okay, so here we go. An investment account pays 4.2% annual interest, compounded monthly. If the $2,500 investment in this account, what will account balance be after 15 years? Okay, so what do we have? We have compounded monthly, so I know the N. That's the N. I know it's 12. I have 2,500 invested. 2,500 invested. So what does that mean? That means that P is 2,500, and then I have my rate, 4.2%. Trying to go color coded here, 4.2%. Oh, I don't really have a pink up there. Guess we'll just go with this one. So my R is 0.042. And then lastly, the 15 years would be time. So T is 15. Okay, plug and chug. Here we go. A, I don't know. That's what I'm looking for. What will the account balance be? P, I know that, 2,500. 1 plus the rate, I know that, 0.042, divided by number of times compounded, 12, to the number of times compounded. Some of you, I would go ahead and put that in parentheses, times compounded times the number of years. Okay, if you need to, if you're scared, go ahead and actually just change that to 12 times 15 to 180. Okay, so if you're scared that you're going to mess that up, that one I would go ahead and say that you can go ahead and change that to 180. Okay, because it's 12 times 15, so 180. Okay, now guess what? You should be able to plug this all in at once. Again, I'm going to read it to you. So here we go. 2,500, parenthesis, 1 plus 0.042 divided by 12, parenthesis, caret top. Now, because I already did the product of that, I don't need a parenthesis, but 180. You should get a whopping $4,688.87. Woohoo! All right, 15 years. Didn't even double your money. That stinks. Okay. Just going to do one more quick last example, and then you have one more assigned problem. So Jerry's grandmother invested money into an account when he was born. He was not allowed to touch the account until he was 25. When he turned 25, there was, okay, so that means there was, that's the A. You know how much you ended up with. He knew that the account gained 5% and is compounded weekly. So how much did he originally put in? Originally put in is the P. Okay, so I know that he ended up with $34,882.48. I do not know the original amount. I know it's 1 plus the rate over 52 weeks to the 52 times 25. And if we want to, we can go ahead and change that 52 times 25 to 1,300. 1,300. Okay, so just let's figure out what this is. Blah, blah, whoops. Ugh. You guys getting sick of me doing that part? All right, so, okay. All right, so let's do this. Type this into your calculator and get a number because you need to follow order of operations. Parentheses, exponents, then multiplication. All right, so let's just get a number for all of that mess. So parentheses, 1 plus 0.05 divided by 52. Parentheses to the 1,300. Hit the wrong key. There we go. Okay, so you get about 3.48. All right. So I end up with $34,882.48 equals P times 3.488. And then what are we going to do to solve for P? Divide. So when I take 34,882.48 and I divide it by 3.488, you get pretty darn close to 10 grand. It's pretty sure Granny put in 10 grand. So that's what my P is equal to. So 10,000. Thanks, Granny. All right. But, you know, she invested 10,000 and you ended up with 34,000. That's pretty good. Okay, so here's your last assigned problem for the day. Beep, 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 beep. All righty. So if you want to hang out and check your answers, you can go back and do that. I'm going to do that now, but you are to do that last assigned problem, and then you're done. If you want to check your answers, great. Okay, so for those of you that stuck around to check your answers, thanks for doing that. All right, yeah, because we're like at 20 minutes right now. Okay, so just really quickly, so it contains 180 milligrams. By the way, yeah, you're only recommended to have 100 milligrams a day. Eliminates, oh wait, you know what? I forgot this one. There we go. Teen spending. Okay, so grown 3.5% from 2006 to today. Spending was 79.7 billion in 2006. How much was it in 2014? Obviously, I didn't update this worksheet from 2014. Okay. So what's our total amount? That's what we're looking for. Again, I told you not to actually convert that, so we're just going to leave it as 79.7. In this case, 1 plus 0.035. So from 2016 to 2014, that's 12 years. So we just type that all in. It's not 12 years, guys. Come on. What? It's 8 years. Math's always been really hard for me. Okay. 8. Okay, so we got 8. All right, so we end up with 104.94 billion, which actually pushes it into the trillions, but that's how I'm going to write. That's how I wrote the problem. 104.94 billion. All right, now the cappuccino or frappuccino, whatever, whatever. All right, so contains, this is the principal. We have 12.5%, that's the rate. After time, that's 3. So we're looking for the A. So it's just 180. 1 minus 0.125 to the third power. 180, 1 minus 0.125 to the third gives us 120.6 milligrams. Still more than what's daily recommended dose for you guys. Oop. All right. And this one. Okay, so again, I helped you out here. So the A, we ended up with a total. I knew the principal amount was 25,000. 1 plus the rate, and it was 7 years. Okay, so it did say grow, so that's why I know it's a plus. Okay, this one was, do you know how to solve equations correctly? Okay, order of operations, parentheses. Well, I can't do that because I don't know the power, so, or I don't know the R, so I can't take it to the power, so I can't multiply it, so I'm going to need to get rid of this 25,000 first. So 3,888, whoops, too many 8s, 49.66 divided by 25,000. Okay, so I end up with 1.554 approximately equals 1 plus r to the 7th. Okay, we just finished up exponential equations, or excuse me, we just finished up radical equations, so hopefully we would know that we would have to take the 7th root of this, which again, we should be able to know that that's the same thing as the 7th root is this to the 1/7 power. Okay, we just finished that problem. So 1.554 to the 1 divided by 7th power gives me 1.065. Subtract 1, I get 0.065. So what is the percentage rate? 6.5%. All right, and the last one. So we are looking at compounded every 2 weeks. Compounded every 2 weeks. Okay, so we initially deposit 500. 1 plus the rate, 0.0225, every 2 weeks. Okay, so if there are 52 weeks in a year, going per 2 weeks, that's 26. So it's 26, and then 26 times 6. And once again, if you would like, we can change that 26 times 6 to 156. Okay, so type it all in, 500, 1 plus 0.0225 divided by 26 to the 156. So a whopping $72.23 is how much you made in 6 years. Don't quit your job. All right. So I know that was kind of long, but you're done for today. So yay. See you later.